Greetings. My name is Christopher George. I'm a Safety Agency and Validation Test Engineer with Eaton Corporation. It's under the Electrical Group and Power Quality Division in Raleigh, North Carolina. What we're standing before today is the 1100 kVA 9395 UPS system. This system employs transformerless double conversion topology along with the energy saver system and variable module management system under the energy saver architecture that has been recently released to the public. We're standing in front of the input-output section of the Integrated Service Bypass Module, or ISBM. A quick tour around this section, as you can see, the battery plus buswork connections, the battery minus buswork connections, the output buswork connections with neutral buswork along the bottom, the bypass buswork connections, and the input buswork connections. Again, it is noted that this is a design and engineering setup, and in normal operation these wires would not appear as such, as they would be properly landed through conduit and dressed in this section accordingly. As well, you can see that there is a battery plus connection with a wire that follows down to the bottom of the unit and a chassis ground connection. That wire follows down to the bottom of the unit. These wires follow out around the back to a 1600 amp fault breaker that's to the side of the system. Now to the side of the unit, we have the 1600 amp faulting breaker that we're going to use to apply the short circuit mentioned previously. Again, that is to the battery plus connection to the chassis ground connection. We will use this control to apply that short circuit. So here I'm putting the dead fronts back onto the unit for safety. And as well the final front bezels. It's also a point of note that the unit seems very tall. It's mounted on not only its shipping skid, but also an extra layer of dunnage so that we can maneuver the units in the laboratory. Normally, they would be about 8 inches lower than this height. Now the system is running online in double conversion mode. It's fully loaded with a resistive load at 1000 kilowatts. The load bank is located outside with a control panel on the back wall. The system is also fully metered for input and output voltage and current, as well as the fault current that we're going to see on the battery. These images will be captured on an oscilloscope that's off to the side of the system. As you can see here on the meter screen, the unit is fully loaded and the current is presented here as such. With the system ready, now let me prepare the faulting breaker for test. And now we're prepared to perform the fault. Fault! The images displayed here show the fault that we just applied to the unit. They represent the battery plus to ground condition. They demonstrate the robustness of the 9395 product. The unit emergency transferred to bypass and maintain the critical load.